For this assessment, we use ZAP by OAuth to scan the vulnerabilities that happen in this website. So we just paste the link and we attack the website. So at the bottom of this page, we can see there is the history of this website. We can see the method, the post get, which is the request response method in this website, and we just wait until it is fully successful done. So yeah, there is the get post, and then we can see the link, the timestamp, the reason, the code. So it will scan all the vulnerabilities. So it's done. We can see that there is the colorful flag, which the highest is the red flag, the SQL injection. So the evidence is you have an error in your SQL query. So the SQL injection may be possible, and then we can see the absence of anti-CSRF that can lead to the XSS. So these the vulnerabilities that can happen in our website after we scan. So I will demo the SQL injection by using Manual Explore in ZAP. So we just paste the link of our website, and then yeah, we paste this login page. It's just a link. So we use the Chrome and we launch the browser. So this is basically the browser that linked to the ZAP. So we just continue on. So we log in by any username and password. Yeah, and as expected, we are failed. So we can see at the bottom of this page the history of this website, and then we go to the file of this website, go to the car, and then we go to the post, which is the login page. And then we can see the requests that we made earlier, admin and pass. And then here we will launch the attack. So we right click, go to the attack, go to the pass. So we can see the request we made, and then we select the username, and then we add, we can add the file parsers that is already in this file. So we just click the SQL injection, and now we can see all the cheat code for in SQL injection, the payload. But in this demonstration, I will use my own file. So here we see. So we go back to the file, and then we select the file that I have. We have to find the file first in the directory. Download. So, okay, there is the SQL list. We open and then we add. So this is the code that I made. We add, and then we click OK, and we do the same to the password. We add the same file. On the download. Okay, there's the SQL list. When we add, click OK, and then we start further. So when we start further, so it is running in our website. As you can see, there are so much reflected, which means the website has been attacked by attacker. The process will be long, so we just have to wait. So we can see there is the reason. And then we click on the reflected. We can see, yes, the reflected, we can see that you have an error in your SQL syntax. So it means that our SQL injection is a success in this website. Yeah, you have an error in your SQL syntax. So this is how the attacker attack the SQL injection in a website.
Next, I'm Yasmin and I will continue with the demonstration of the cross-site scripting penetration test. I use a web step for a vulnerability assessment towards this web application. So here we can see that this tool identifies that this web application is vulnerable to cross-site scripting. It means that an attacker could inject malicious script into this application, steal user cookies, and even redirect user to malicious sites. Okay, now I'm going to continue with a demonstration. I'm going to inject the payload in the add new car form. In this name section, I will try to insert script alert XSS script. Then I will continue to fill in all these requirements. Now I will submit the form and here we can see the successful pop-up bar appear. And once I click OK, another pop-up bar appear again. So for now, I will just click OK. Now I will show that the injected script is executing wherever the vulnerable data is displayed. I will try to move to the list of car section and the pop-up bar appears again. And it same goes when I move to the home section. Next, when we look at the list of car, a new car is listed, but the name is missing. Thus, the related functionality such view details, uploads, and deletes are not available to function. Now I'm going to inject the payload in the update details form. In this name section, I will try to insert script alert document.cookie script. Then I will continue to fill in all these requirements. And now I will submit the form. And here we can see the successful pop-up bar appear. And once I click OK, another pop-up bar appear again. Then we look for the list of the car section. The picture and the name are not being displayed. Thus, I can conclude that the injected payload in both the add new car and update page will trigger the car list section. This not only compromises user security by enabling potential cookie theft or session hijacking, but also will disrupt functionality by breaking the critical features such as updating and also deleting.
Now, let's move to the next part, which is code review. After reviewing the code, we can find a few vulnerabilities from the code. One of them is SQL injection. SQL injection occurs when user input is inserted into SQL queries without proper sanitization, which allows attackers to manipulate the database. One of the examples can be seen from the update process file. Focus on line 4 to 6. Here, the values post car name, post car price, and get car ID are directly inserted into the SQL query. If an attacker manipulates the request, they can inject malicious SQL commands into the database. The same issues also occurs in other files such as admin login file, update file, and delete file. In admin login file, in line 8, the value of post admin username and post admin password are directly inserted into the SQL query. In update file, focus on line 78. This line allows retrieving car details for editing by passing car ID in the URL. In delete file, the value of get car ID is directly inserted into the SQL query. How to mitigate this SQL injection? Prepare statement can be implemented to mitigate the risk of SQL injection. Prepared statements ensure that user input is treated as data and not SQL code. For example, in update process file, firstly, we can validate car ID as an integer. Then, prepare SQL statement and binds parameter to prevent SQL injection. From the code, we can see SSI, which is S indicates string, that is used for car name and car price, and I indicates integer used for car ID. This will ensure that car ID can only be an integer and cannot be exploited. The same method of mitigation also can be implemented for the affected files, which are admin login file, update file, and delete file. This prepared statement prevents query manipulations, where if an attacker tries to inject code using SQL command, it will be treated as a string instead of SQL code.
Next is cross-site scripting. Cross-site scripting is a security vulnerability that allows attackers to inject a malicious script into web page viewed by other users. The risk for this attack is attacks can steal sensitive data, hijack session, and perform action on behalf of the user. Here is the example code segment on at car.php that have a vulnerability to get attacked by cross-site scripting. How the attack happened? Let's focus on this coding, which is car name line as example. The attack happened when the attacker put a malicious script into car name field. As example here is script alert SSS. When the add new car button is clicked, the script will be executed when the page load. The output can be seen on the right picture here, where the page show alert SSS. If this script get into the database, this SSS name becomes store SSS, since script stay in database and execute every time the page load. To mitigate this SSS attack, we have to sanitize user input. Use HTML special char to convert special characters into HTML entities before displaying input. And here is the example to use HTML special char. And next is validate input to ensure that input are of the expected format, like number for price and mileage. And here is the new coding that have been changed to avoid cross-site scripting attacks happen. That's all for me. Thank you.